In section 10.2, we learned that when an angle has its vertex at the center of a circle, the measure of that angle is equal to the measure of the intercepted arc. So the measure of the central angle is equal to the measure of the intercepted arc. Now if we take that vertex and we stretch out that vertex and place that vertex on the circle, we end up with an inscribed angle. So if we have the same intercepted arc, AB, but instead of the vertex of the angle being the center of the circle, we stretch it out to be on the circle, we end up with an inscribed angle. It's an angle inside the circle, where the vertex of that angle is actually on the circle. Now if you look, this angle has gotten smaller. So if I need to find the measure of angle APB, I'm still going to use this intercepted arc, but I need this angle to be smaller. When I move that vertex onto the circle, that angle gets smaller, and it turns out it gets smaller by exactly 1/2. So the measure of an inscribed angle, where the vertex is on the circle, is equal to 1/2 the measure of the intercepted arc. Let's look at some examples. Example 1. We have angle APB. A to P to B is a central angle. And a central angle is equal to the measure of the intercepted arc. Well, in this case, angle APB is going to be equal to the measure of arc AB, 45 degrees. If we look at angle ACB, A to C to B, the vertex of this angle is on the circle, so this is an inscribed angle. And the measure of an inscribed angle is 1/2 the intercepted arc. Well, the arc AB is still 45 degrees. So the measure of angle ACB is 1/2 of 45 degrees, which is 22.5 degrees. If I want to find the measure of arc AC, well, if I look, BAC is a semicircle. And if AB is 45 degrees, these two together have to be 180 degrees. So to find the measure of arc AC, I need to take 180 degrees and subtract 45 degrees. And I get 135 degrees. In example 2, I have angle CAB. C to A to B is an inscribed angle. So my formula is going to be 1/2 times the intercepted arc. The intercepted arc for CAB is arc CB. And the measure of arc CB is 60 degrees, so the measure of angle CAB is 1/2 of 60 degrees, which is 30 degrees. If I look at angle ACB, A to C to B is also an inscribed angle. So my formula is going to be 1/2 times the measure of this intercepted arc, arc AB. But I don't know how big arc AB is. But I do know some things about this shape. If I look, angle CBA is 85 degrees. So CBA is an inscribed angle, which means the intercepted arc is going to be double that measure. So to figure out the measure of arc CA, I need to double 85 degrees. When I double 85 degrees, I get 170 degrees. So the measure of arc CA is double the inscribed angle. So if I have 60 degrees and 170 degrees, I need 130 more degrees to get to 360. So to figure out this arc, I double the inscribed angle. To figure out this arc, I need to find the total 360 degrees. So heading back to angle CACB, I'm going to have 1/2 the measure of the intercepted arc. So 1/2 of 130 degrees is 65 degrees big. Now if I look, I have a triangle. I should be able to take 85 degrees and 65 degrees and 30 degrees, and for an answer I should get 180. And when I check that, I do get 180 degrees. So I know my numbers check out. Now I need to answer my last two questions. Arc AC is 170 degrees, and arc AB is 130 degrees. Now let's look at Theorem 10.10. Theorem 10.10 says that we can inscribe a quadrilateral. We can put a quadrilateral inside of a circle where all of the vertexes are on the circle if and only if the opposite angles are supplementary. So in order for this quadrilateral to be inscribed in the circle, the measure of angle E plus the measure of angle G has to equal 180 degrees, and the measure of angle D plus the measure of angle F has to equal 180 degrees. Let's use that to do example number 3. We have a quadrilateral, and in order for this quadrilateral to be inscribed inside the circle, the opposite angles have to be supplementary. So we can set up two equations. 10x plus 8x has to equal 180 degrees. They're opposite, they have to be supplementary. And c plus 2c minus 6 has to also be supplementary. Opposite angles have to be supplementary. Now I can solve for x. And I can solve for c. (186 divided by 3 is 62).